we're still working on a conversion tool, and we'll let you know about that later.
Also, the code is much friendlier. The Go code is much friendlier, so you can also contribute yourself if you want to add a feature and send a pull request to Sebastian or Guijt. So,
any other questions? No.
Who's going to use it tomorrow? Yeah. For which one? For me? Ah, nice.
Round of applause.
Yeah, please give Sebastian another round of applause. So I was thinking what to tell about you. It's like an ex-intern, and you're actually our first intern.
I was the first. Yeah, I started all the.
So in the data part, right?
Sorry.
Yeah.
Rick Assies.
Yeah, but it's like sales. And actually, you. And after that, in the big data team, and now at the Flora Holand big data team. Please give a round of applause for Dirk.
Hi, welcome everybody. My name is Dirk. Half this room probably knows me because I've been roaming this building for almost 4 years. First as an intern, indeed, and then as a data scientist. I now work at another place, at Flora Holand. It's a flower place, and you might be wondering, what do you do there? Well, when I left, I told everybody I was going to sell flowers, but I'm also a data scientist there, so I rather talk about all of that stuff. I want to tell you one of the use cases, one of the projects I've been very involved in, and it concerns a lot of images of flowers. So, I work at Royal Flora Holand. Who doesn't know Royal Flora Holand? Almost nobody. Well, it's the biggest flower auction in the world. I'm actually located in Alsmeer, so it's really close by. It all started more than 100 years ago as a cooperative of growers. They all bonded together to have a stronger position on the sell side of the flower business. It's been very old, and well, today I think we auction 6.7 billion plants and flowers every year, so it's quite a lot. Some other interesting facts which I want to share is that we receive 50,000 tourists every year that come watch at our Alsmeer site. If you want to come, it's really close by, and you can just walk in. Basically, it's not much security. The service area, well, yeah, it's open. Like all the buyers are also located there. So. The service area of all auction buildings combined is bigger than Monaco, so it's pretty big. And then Alsmeer building, which I work in, is actually the biggest one, biggest building in the world by surface area. There's 4 bus stops at that site, and if I walk back to the cafeteria for lunch and back, I walked 1.5 kilometers. So it's really sometimes it's nice, sometimes it's not so nice. But yeah, it's very big. Like the scale is very big, and you can also see that in this picture, which is one of the flower halls, where all the pictures come in and are distributed. This is just a small portion of what we handle every day. You can see flowers as far as the eye stretches, and it's a lot. How does the auction process work? Well, all these plants and flowers, I'm actually getting a bit nauseous from the screen movie. What you see is all kinds of buyers here on the stands, and they see what's all on the clocks. There's 6 of these halls, and there's 35 of these clocks, and all the goods are auctioned on the clock by using the Dutch auction system. I will tell you later what it is. And what you see here is that all the goods come by. That's also actually what's on these clocks. And they basically buy it. You can see the auctioneer sitting on top of there. They are leading the auction, so they talk to the people buying it. And next to this, there's also a whole bunch of people buying remotely. So from all over the world, people can join in and join this bidding process. Once the flowers are sold on the auction clocks, it goes through this process, which is like really a lot of fun to watch. This is taken by a colleague of mine, this small video. what happens is that people buy, might buy one of these cars, and what they then do is they bring this car to position there, they bring it to the box of the customer who bought it. So it will be delivered at this box. But sometimes somebody also only buys like a few buckets or only half of the carton. So these people, they actually distribute it across all of these boxes, and they bring it to the two persons who sold it. So this is going on every day. Auction starts at 6. And then this goes on, so I think their target is always to be done by 1, I think. But yeah, this is today. It actually started a long time ago, as I said, in 1911 in the end, the first auction, well, there were many auctions, but they all merged now into what now is Flora 1. But the first auction that was founded was in 1911, and what they did, they went to a bar, a pub, and they brought all the flowers over there, they put them on the pool table, and then this guy would stand on top of it, and he would basically just start showing products and shouting prices. And what he would do is that he would over time lower his prices until somebody wanted to buy it for that price. So basically the first one that says, mine, I want these flowers, go buy it for the price he just mentioned. And this is called a Dutch auction system, and that's actually still used today. So of course things changed over time, so here you have already, there's the notion of a clock, and you also see all the goods come by in front of the clock. And what now happens is that that clock starts at a high price, goes down, and the first one who, again, wants to buy the flowers at a certain price point is able to buy them. Now this got a bit modernized, of course, over time, so this is already a bit later. So now you have the stands where people sit, and this is already a bit more modernized or automated. Of course, this process went on, so this is already a bit more, as I've shown you before. People sitting on the stands, there's a digital clock, and the goods come again in front of the clock. And nowadays it looks like this, or I just showed you a video, this is also another hall. So you now have this fully digitized system, and people can log in remotely on their laptops, and they see a version of this, and they can join the bidding process. Now we come to a problem that I want to talk about, and that's because in the past, they actually got to see the flowers. They actually saw the flowers in front of them that they were going to buy. And there were actually people who were called opstakers, who would take a bucket from the cart and would show it to everybody in the stands. And well, they would say, well, buy this, buy this. And nowadays it doesn't happen so more. So the hall you just saw, there's still flowers in front of it, but in many halls it's actually not the case anymore. And also, because people are buying remotely from all over the world, they can't see it anyways, even if it would be there. So it becomes more and more important that the growers, the people who grow the flowers, deliver a nice picture of their product that they're auctioning. And well, this is sort of a problem because they're not always very good in making a nice picture. And so Flora Holand is starting to enforce rules on how the picture should be taken and what should be on a picture, so that the pictures are very similar and you can compare the products. That's a good thing for many reasons. One is that the pictures are also used on websites for the customers of our customers. And if you would have the same product and everybody would make their own flashy pictures, which is actually what is happening, well, you would get this whole rainbow of flowers on your website, and it's not really good for sales. And also, if you want to compare these flowers on the clock, it's very hard if everybody takes it differently. Like you wouldn't know the scale. Now there's a tray behind this, but you can't really tell the scale if only this thing would be on it in the picture. So yeah, sometimes there should be, for example, a ruler on the photo to show this. Sometimes if you deliver it in a tray, there should be one item should be in front of the tray so people can see what the actual product looks like. And I think Paul gave a talk about colors in pictures once at was not you? Oh, I thought it was you. It doesn't matter, but like if people, for example, put a black background behind a picture, the perception of how you look at these plants changes as well. So that's not good. So we want really white backgrounds. Or in case of white plants, it can also be gray. But anyway, there are now rules to say like this should be in the picture. And you can imagine that for all these goods, every day there's a picture taken which should be recent. That's really hard to do. If we would hire a team to do this, I mean, it's impossible. It's just too much to do by humans. So that's where I actually come in as a data scientist. we started thinking about, okay, can we automate this, and can we have the computer look at these pictures and see if elements are present? And so we did. So we used something that's now very hip and cool in data science. It's called deep learning. Who has heard of deep learning? Who thinks he knows what it is? Okay, I won't go too deep into it. I can talk about this for an hour as well. Basically, we used a deep neural net, or we trained deep neural nets for various elements that should be present on pictures. For that, we used TensorFlow, which is a really popular backend for doing deep neural nets, and you can define them in there and train them. On top, we used actually Keras, which is an abstraction, a Python library, an abstraction above, on top of TensorFlow, and also other backends like Theano, or this open source Microsoft thing, CNTK or something like that. But you're able in Keras to define the network, so the shape of the network, of what it looks like, and it takes care of all the backend, the TensorFlow stuff for us. So yeah, what we can then, for example, do is train, okay, we have pictures of plants, and we have pictures of other things. And we use the C410 dataset for this. And then we can train the neural net to define whether this is a plant picture or not. So that's one of the properties we do. And training a neural net of a fairly large size yourself from scratch takes a really long time. So what we also did is use a pre-trained network, in this case VGG16, which also comes with Keras, they have many pre-trained networks. And the idea behind a pre-trained network is that somebody already trained a neural net to discover all kinds of things on pictures. So they just took a data set of a lot of labeled photos, and they trained a network on it, and what it's really good in doing is then determining for certain categories what's on it, or something like that. And what we do with a pre-trained network is something called transfer learning. So here we have a representation of a neural net with the different layers, and it is trained to do this particular thing that somebody has thought of. What it actually does in like all the first layers is learn features about the image, like is there a white, or is there what do you call it, a flock, an area like a surface area, or a cube, or a circle, or is there a rectangular object in it. So what it's really good in doing is finding these type of features in an image. And the last layers then do some classification based on these features. So what we do is we take out this last layer that does a classification, but we keep all the part of the network that determines all these features, that can find all these shapes and colors in there. And then we basically just retrain it with our own purpose. So if you want to know if there's a ruler in the picture, we train it for pictures that have rulers and don't have rulers, and those type of things. And by doing that, we can basically create our own awesome, really good working neural net. So what we did is we put this whole thing in a console application, so we can basically point it to a data set with labeled photos, and then it will train a neural net for us. So it's really, really easy for us to train new models. Now, our team really likes to give names to services and components that we build. We're a bit unorthodox in that. And we also really have a lot of discussions about this. This particular component that trains deep neural nets is called Mariana, and it's called Mariana because of the Mariana Trench, which is the deepest trench in the world. And somebody decided, well, that should be our name. So this thing is called Mariana. It gets way worse the further I go in this presentation. So what we also do, not every problem has to be solved with deep learning, because it's now like the holy grail and everybody applies it to everything. But there's also simpler, like problems that are much simpler can be solved other ways. So for that we have a heuristics-based package similar to Mariana. It's called Eureka. My boss is really good at thinking about heuristics, or so he says, and that's why this is named like this. And through that we can train simpler models than just deep learning stuff. So now we have trained a bunch of models for rulers, for background, for if there's a tray in the picture or not, if there's a bucket in the picture, and like all these things we can train a model that can determine for a picture if it's in there or not. But of course, we cannot just give this to some team and say, well, here's a model, use it. So obviously, we wrap an API around it, and we put all the models in production. I will talk more about it. And people can call it, can call the APIs with a picture, and it will tell what's in it. We put this all in a Docker container. I don't think I need to explain why we want to put it in a Docker container. It makes it very flexible both to develop and deploy in all kinds of systems. I think Docker is awesome. Never worked with it at Sanoma though, for some reason. Don't know why. Yeah, and then what we can do is we can call the API with all the models in it, and it will give you back for each thing that we have. It will give back some. It's not a probability, but a score for how certain it is that this particular property is true for this picture. But of course, we're not there yet. If we have this, then well, that's already great. That's maybe the hard part. But we also need to determine now if this picture, if the picture is correct or not. If all the elements that should be there are there, and all the things that are there that shouldn't be there are not there. So we take the core photo standards as they are defined by the business. All kinds of requirements based on the product code and based on the FUST code. So FUST is basically the container in which the products come. So in this case, it's a tray. It could also be other things. But we also need that part to determine if a picture is correct or not. So we also build a decision engine. We put a rule-based system in there with all the rules that have to apply. We also call some additional APIs. It's not really important, but based on the product code, we can find all kinds of metadata about the product. So we take all that in. That API also calls magical, asks, okay, this needs to be in the picture. Is it truly there? So all the deep learning and cool stuff happens there. And then it tells you if it's correct or not. That API, we also gave a name. It's called Judy. And it is called Judy because it's a decision engine. And we named it after Judge Judy, the famous judge. I think we have great meetings about all of these things. It's really fun. So you would say, okay, now we're done. We can put a picture in Judy. Judy will determine if it's correct or not. But as many data scientists would know, it's actually you're not there yet because you also want to know what's happening. Like how is the model performing? Does it work? Does it keep working? Does our environment change? Do the rules change? We need to monitor somehow our models. So we want to know something about the accuracy of our models, and we also want to know if we can get more training data or more, if there's more examples of pictures that we want to have. So we also built a feedback API. It's called Poke after the image catalog. What you can do basically to this, it's a very simple component. You can put a picture in with a few labels, and it will store the image on S3 with the labels. We also hash the image based on content. If you want to know more about it, look at that GitHub page. But basically, we can give a unique hash for the image based on what is on it. Now that we all have this, we started also to talk more to the quality department. I once went with them actually to see how they work. They are the ones who actually check if the photos are good enough, if the products are good enough. And what they do, there's these giant cooling cells with all the products lined up in them. And what they do is they look up in the system what has been delivered, and they go with his card and his laptop, he goes through them and he checks what's on the cards and if it makes sense and those type of things. And he can no way check everything that's been delivered. But yeah, he's at least a person who can give us some feedback about it. But we cannot, of course, tell to him, well, just call these APIs with these images and go ahead and do something. So we built something for that. We built a tool in which he can export the stuff that is been delivered to an Excel sheet, and then he can upload that Excel sheet into our system. It's great for integration, but he can upload it, and then we will tell for every line in that Excel file if the image is good or not. So we call this system excellent. And what you can basically do in it is, well, you upload your Excel, you get to see the picture, some data about the goods themselves. You get to see a few switches with all the properties that we make predictions for, and he can tell us, oh, this will be predicted by us, and he can correct it or not correct it depending on what happens. So these come from Judy. And then you can store it, and they get a record for themselves to see, well, these products are good or not. And we also get labels back that say, hey, this is a good photo, or this is not a good photo, and because of this reason. Yeah, so it sends it back to Vogue. So yeah, by having this, we can do two things. One, we can see how our model prediction, how it performs. So how many times does it say photo is correct or not for every element. So we get to see something about the balance of the photos that we get, both in terms of what we predict, but also what's the reality. So we can compare something. Yeah, we can say something about how well our models are doing, or if it's doing something funky. So that's basically the whole infrastructure. So I put it also on a bigger slide. This is maybe now it becomes maybe more interesting for the whole tech department. Everything is deployed on Amazon. So here on the left side we have our users. So our own flower selling platform. There's a photo app through which people take pictures and can send it to us for the auction, and it will. The goal is to also automatically at that point already do a prediction if that's a good picture or not. And there's also third-party vendors who can give access to all of these APIs. So they connect through the API gateway, which I think Bas already mentioned. It's from Amazon. What the API gateway does is also called a Lambda function, and that checks authentication. Okta is a third-party single sign-on solution. So every call that goes through there will be checked if the call is valid. It's really useful because then we don't have to do it anymore. Basically behind that we have Judy, which I talked about. We have Magical, the excellent services there. We have Vogue, and Vogue stores info history. Then we have Airflow as a scheduling system, which can take all the training data that we have gathered, and maybe on a weekly schedule or daily or monthly or whatever we want, we can retrain our models. It will publish the models to the Artifactory that we are running, and from there we can also trigger a deploy. So Magical will get redeployed with the new, will pull on the new models, and then well, we have a full cycle. Also, we have this bit of an ugly thing here. It's due to legacy reasons we still have it there. I'd rather have this in this environment here, but we're working on that. So yeah, all in logging and monitoring, we do everything to CloudWatch and use Grafana to make nicer dashboards than CloudWatch itself provide. So there's this. Then maybe something a bit more into the Go domain. We built all these Python APIs, and we have built it with Python, not with Go. But one thing we like about Go is the asynchronous stuff. Are you going to tell something about it? Yes. Okay, then I won't. But what you can see is that there's a lot of I/O going on. We do a lot of network calls, we do a lot of file system call databases, and well, hopefully you maybe will explain. In this situation, it is much more useful to use an asynchronous infrastructure, so we don't have to wait on all these things, and we don't have to scale our system up really big. For that, we used an API technology very similar to Flask. It's called Scenic. And it's basically, this is truly like, it's not like I can make this up, it's really on their page. It's basically Flask, but it can handle asynchronous API calls. And I think it's really useful. It's kind of young, has maybe some quirks, but for us it has been working great. And yeah, I have did some benchmarks, and I think we're quite happy with it.
Yeah, have you looked into API Star?
Sorry?
Have you looked into API Star from the maker of JavaOS framework?
No.
It's an async framework.
I don't know.
Well, basically it's what you just mentioned, but it's
okay. Well, maybe worth investigating. Yeah. I will ask you what it is, and I can have a look at it here. But we have basically made a Docker image with this in it, and so we only have to all the APIs look the same except for the endpoints and what they do. That's pretty nice, I think. Yeah, so I think this is also. Oh, it doesn't update here. Great. Yeah, great. So Magical is basically the powerhouse because all these things they take in data and they send it through in some form or other. But Magical is really doing all the work, and we noticed that it wasn't like the performance was a bit down. If we run all these models on our own computer, it's fast, and then we put it on Amazon in ECS, and it's slow somehow. So we started to investigate how we can get better performance. So if you look into Imagical and what it does, then once it gets an image, it reads and parses the image, obviously. It resizes it, so it's the same size as the network, the neural networks have to take in. It runs the image through the first layers of PGG16, so the whole 22 layers, I think, and all the 138 million parameters. So it runs it through that, and then the output of that is run for each model that we have. It will just run the final layers for that. So it's actually doing this sequentially, not parallel, but you get the picture. And then in the end, we gather all the data and we have our answers. Now, we benchmarked, of course, all of these steps, like why is it slow? And obviously it was slow because of PGG16. It's really, the network is really big, and on CPU it takes some time. It took 1600 milliseconds for a call to come back, and that's really way too long. It's good for our batch processing, it's fine, but for the phone app, for example, we just want an answer really quick. So we have actually two types of loads, so we needed to get this quicker. All free advice. We started working on this when TensorFlow was still at version 1.4.0 RC1, and well, by the time I made this presentation, 1.8 was out. It became a lot faster. We were now in like 900 millisecond range, so that was already a big step for us. But we also tried different Amazon machines for the purpose. So TensorFlow scales really good with having more CPUs, and it's even better if you put it on a GPU. So we tried for all these different machines, we tried to run under full load, so constant load. We tried to see how long it would take to run a number of images, and then we just check how long it would take to do this. So you can see that if we scale up these machines, it becomes a lot faster, and if you put GPUs on it, then it's really, like it was in the 50 millisecond average range, so that's really, really quick. And we did this within 1 week, going from 1600 to 50 milliseconds, so that was a good week for us, I guess. But of course, there's no such thing as a free lunch, so you also have to pay for it. So the red line is the on-demand pricing. I'm aware you can, of course, do things with spot instances and whatnot, but this is the pricing. So you also see the price go up, but you also see this like horizontal line here while performance goes or is getting better. So you can also make this price performance image, which I obviously did, and you can see what it would cost to process 100K images under full load. And then you see that actually, even though this machine is fairly expensive, still under full load, it's by far the cheapest option if you want to run all this. So I think this benchmarking was really nice. But this is of course under a synthetic load of 100K images. It's running through them under full load constantly. What we also did is then, well, we don't have that load, so we look into scaling more. The blue line is, for example, our load. It's a synthetic load, but it goes up, it goes down. At one point we have more images, other less images. And if we would have one big machine that can do everything, so a really expensive one, then you have, for example, the purple, or is it pink, purple line. And obviously, we can handle all of our load, but it's also costing us a lot. Especially when the load is going down, we still pay a lot of money for this machine, which is doing nothing half the time. We can also go with a lot of small machines, then we can scale much better with our load. The problem is that we also have this phone app, which has to have big response times, and the small machines don't have the good response times. So we have to find some middle ground with, well, somewhat medium machines, I suppose. We're trying to find a good way to do the scaling. We've been looking into various options. So we were running on ECS, just have a cluster running also for other teams, and it's just running on there. Then we looked into AWS Fargate, which is basically ECS without the cluster. So yeah, probably some of you are familiar with it maybe. But you don't define your own cluster anymore, you just run a Docker container on wherever. It's really promising, I think, but it only allows somewhat smaller Docker containers, so you don't get a lot of CPUs. So for us, it's maybe not fast enough for this particular application. We also we're looking into Kubernetes, which is getting more popular. I don't really understand. Like I was sitting with Sander at the AWS Summit actually trying to listen to a story while he was trying to eat his dessert. I was really, yeah, it was a lot of story about Kubernetes and Fargate, and I really don't understand why they have it both. Yeah, it's popular, but I think you will, like running things on Fargate will be better in the future. So I think. Also, what one of our engineers is figuring out to use Spot Fleet. So instead of, well, we basically construct our own Fargate for Spot instances. So we can just say we need this much processing power. Try to find it on Spot instances. Do whatever you want in terms of which machines we have defined, but it can guarantee you that it has that load. And if it's not available because there's no Spot instances for a really cheap price, then run it on Fargate or do something else smart. So I think, yeah, by using the scaling, we can still make this very heavy application cost effective. So I think it's really interesting. Okay, I'm almost done. So next steps. This is something that I was working on last week, actually from scratch. What we did is. What we now did until now is not saying, okay, is there a ruler in the picture? Is there a tray in the picture? Is this in the picture or not? What they also want to know for some other reasons is where in the picture is this this particular element. So I trained a model that can find text and logos in images. What I did is I took I think 1,000 images that were completely clean of this. So I used the quality team's feedback to find these images. There's no logos, no text in them. I then downloaded a logo data set and our own logos, which is a data set of 4,000 logos, and just randomly put text and logos into these images. And then obviously I know where they are because I put them in there. And I can train a model that is going to try to find logos and text in images that are actually real. This has actually been submitted by somebody. This is not constructed by me. But you can see that it already finds a logo and some text. And this was really like the 0.1 beta test. It also sometimes does not work well. So somehow here it thinks there's a text over there. Why? I wouldn't know really. It's also doing some funky things here. I think we need to work on this a bit more, but it's really promising. By spending 2 days on this, I already got this to work. So I was fairly happy. Some things we learned. I think it's good to do these projects end to end. I know from friends who work at other companies that sometimes they, as a data scientist, they only have to do the math stuff, and then the engineers take over for the building stuff, and then some manager talks to the business. We don't do that. We are involved end to end from the start of thinking about these problems to testing it and delivering it. I think it's really important. We also build it iteratively, so don't try to make this like super huge system, but just keep adding stuff to it. The way I told you, like how we built this, is also how it went in real life. That makes it also possible to demo often what you built and be enthusiastic about it, and it also helps other people to get enthusiastic about it and come up with ideas for the system. So that happened a lot where people were like, "Oh, can it also do this?" And I think people who are generally not interested in data science somehow still got involved now. Talk to the end users early and often. I think we missed out on that a few times, maybe. Where they had ideas and we were like, oh, we didn't know. And I think it's good to involve them also from the beginning. And the feedback loop, I actually have a laser, I just now realized. I think for every data science project or model, so Ruben is going to build a model, for example, it's important to add feedback so you know what's going on and not just rely on your test and validation set. So yeah, I think it's great to do everything in Docker. I don't think I need to convince you, maybe I do, but come find me. Also, we try to use as many managed services as possible that we can find on Amazon. So everything you build yourself, you have to maintain. And I know for a fact that working at some other company previously, that there was a lot of self-built stuff. I will not name them. And well, yeah, we now completely go around this problem except for our own, like really actually our own stuff. So I think it's really good. Also, don't throw deep learning at everything. It's not the holy grail to the universe. It's like sometimes it's really good, sometimes it's not. And also, I think it's really good to keep a bit of fun in your team and name all of these things, and definitely spices up the meetings a bit more. So that was it.
of the type of flower. Because maybe they send in a picture of red roses and they are another type of rose. So is it also?
Yeah, I always get this question.
Okay.
So it's a good question, I suppose. But it's not really a problem for us because there's not a lot of people who do this because it's not in their benefit. If the grower sends a completely different plant or flower, you will either get caught on the clock itself. So it will be auctioned. It will say this is red roses, and the picture will say will have white roses. Everybody will see. The auctioneer will mark it, and people will be calling you. Also, if the picture doesn't match in terms of quality or something like that, then by the time the buyer gets the goods, he will call us and say, "Well, this is completely not what they told in the delivery note," and they send it back. And that's also one of the tasks of Flora to do these kind of things. So it's not really a problem. What is a problem is the type of the container that it's delivered in. So, for example, the first bucket, a tray, or a box, or those type of things, they often mislabel those. That is happening a lot. So, whether there's a color on the thing, yeah, okay, it's maybe a bit too deep into the flower. I learned a lot about that actually. But that does go around often, so that we do pick up. But the flower type, we did have a what's it called, a incubator type of thing, with the notion, with the emphasis on have. People were working on this, but it's not really a use case for us. Yeah. Everybody wants food, obviously.
How long did it take to build?
I think from when we had Mariana, once we had that, because that obviously took some research time to just get sorted out, get the training data and those type of things, so it was process-wise longer. But from there to building the system, to have Judy and to have Magical running in Amazon on the API gateway with authentication and that, I think within a month. So that was really fast because yeah, we're like the department I'm working at is quite young, and we're kind of a bit separate from the rest. So we get to have this more startup speedboat versus oil tanker type of thing. So we can just do our own thing and just go ahead and implement this. So yeah, it was one person, me, but in Sanoma. Yeah.
Does it need to be highly valuable?
Well, yeah. So there's two loads, as I told. So there's the batch load of when every day people send in delivery notes and we have to check them, and it doesn't really have to happen in like if it takes a minute, it's not a problem. But for the photo application, it is important that it's working. Even though if it's not working, it will get checked anyway once they submit the picture. So it's not. We don't have to get like the 99.999%. But
and was it also possible to separate that?